Hello, good day, students. How are you doing today? How is your day? How's everybody? I hope we're doing pretty well. I must confess, I am so happy for you, most especially those that are doing the assignment, those that are following up our online training. Please keep it up. We are very happy that you are following the. So far, your work has been very great. So far, you are doing pretty well. We sincerely appreciate your effort. I know the online training to some people is just a new thing. Some it is not a new thing. However, we appreciate you. Once again, I hope you are keeping safe. You are all doing well. Hope you are maintaining your social distance, your proper hygiene, washing your hands regularly under a clean running water. Hope you are doing all those things. Alright, having said that, my name is Mr. Choron. Thank you again. Today again we shall be looking at our topic for today. Our teaching is centered on mathematics. As you can see on the screen, we're going to talk about mathematics, and this class is for the senior class. This is prepared for the senior class, that is from SS1 to SS3, cut across SS1 to SS3. So if you fall under this category, please get your pen, get your paper right now, sit down, listen to the video carefully, and then you do your assignment. Already we have the other PDF format of this lecture. So if you can't get the audio message very well, the video message very well, please do yourself a favor by downloading the PDF format. The topic is statistic. Continuation of what we are talking about in our previous video. However, today we shall be looking at another dimension of statistics, which is measure of central tendency. Measure of central tendency. Take that again. Measure of central tendency. Alright, so let me go off the camera for now so that we pay attention. Now, learning objective. At the end of this lesson, students should know the following. 1. The mean of group data. The median of group data, and then the mode of group data. All this we are going to discuss: mean, median, and mode under what? Measure of central tendency. What is measure of central tendency? A measure of central tendency is a summary statistic that represents the center point or typical value of a data set. I take that again. A measure of central tendency is a summary statistic that represents the center point or typical value of a data set. The measure indicates where most value in distribution fell, and also referred to as the central location of a distribution. You can think of it as what? The tendency of data to what? Scatter around the medial value. In statistics, the three most common measures of central tendency are the mean, the median, and the mode. And by God's grace, this is what we're going to talk about: this mean, median, and the mode. How do we calculate it when we have what? The measure of central tendency. Each of these measures calculates the location of central point using a different method. Choosing the base measure of central tendency depends on the type of data you have. In this point, or in this post rather, I explore this measure of central tendency show you how to calculate them and how to determine which one is best for your data. So in essence, what I'm saying here is, in this lesson or post, I explore this measure of central tendency to show you how to calculate them and how to determine which one is best for your data. So follow suit. Let's go. Locating the center of your data. How do you locate the center of your data? Now, let's look at it. Most articles you will read about main media and mode focus on how you calculate each one, or even sometimes in your textbook it focuses on how you calculate each one. However, I am going to take a slight different approach to start out. My philosophy throughout my blog or my post or my teaching is to help you intuitively grab statistics by focusing on concepts. Consequently, I am going to start by illustrating the central point of several data sets graphically so you understand the goal. Then we move to choosing the best measure of central tendency for your data and calculation. What I'm saying here is, first I will give you the graphical illustration so that you understand the goal. Then I will now teach you the best measure of central tendency, the best measure you can use. Then I will now teach you how to now calculate it. So stay tuned and let's move ahead. But before then, hope you are not just watching the video. If you are just watching the video, please go back and get your pen. Go back and get your book. Open your textbook. We're talking about statistics. Open to statistic page. And then the topic is measure of central tendency. Okay, have you done that? Okay, let's go. Now, the three distributions below represent different data collection. Yeah, as we go further, you will see the distributions I'm talking about. In each distribution, look for the region where the most common value fell. Even though the shape and type of data are different, you can find the central location. That's the area in the distribution where the most common value are located. All right. Now take a look at this graph. Remember I told you earlier that first and foremost I will be showing my illustration through graphs. Then I will show you the best central tendency you use, and then I will show you how to calculate. Now we start with the graph illustration. But here, the graph we are looking at now is called a histogram. Hope we know different type of the graph we have. I'm very sure you are familiar with bar chart, you are familiar with pair chart, you're familiar with histogram. The one we are looking at now, this type of graph, is called a histogram. And we are looking at the histogram of symmetric continuous. Symmetric continuous. Now look at it, the cycle where I have circled it. Look at it, just take a close look at this. By the graphs, the vertical axis is the frequency and the horizontal axis is the symmetric continuation we're talking about. Now, let's look at this. This is a squeeze continuum. This type of graph is known as It's a histogram, but it's a squeeze continuum. Look at this. This is symmetric continuum, and this is squeeze continuum. Now, let's move further. Now look at this. This type of histogram again is called categorical data. Categorical data. Now we try to categorize this data in a very separate way. Now we are looking at the preference ice cream flavor. The preferred ice cream what? Flavor. Now look below, you see the name. These are different type of ice cream we have here. We have the chocolate, we have the vanilla, we have the strawberry, we have the punch. Different type of ice cream. We just categorize it. Now the most important thing here is the graph, and we're looking at what? The categorize data. How do you categorize your data? Look at this. We talk about the squeeze. This is a squeeze what? Squeeze continue, and this is what? Symmetric continue. All right. Oh, having seen this, the three categories of histogram, let's move ahead. As the graph highlights, you can see where most value tend to occur. That is the concept. Measure of central tendency represent this idea with value. So the idea we are representing with what? Value. Coming up, you will learn that as the distribution and kind of data changes, so does the best measure of central tendency. Consequently, you need to know the type of data you have and graph it before choosing a measure of central tendency. One thing you put in mind is what? First, you know the type of data you have. Then the kind of graph you are going to plot. That is what we are saying. Say, consequently, you need to know the type of data you have and graph it before you choose a measure of central tendency. Now, let's go ahead. The central tendency of distribution represents one characteristic of distribution. Another aspect is the variable around the central value, while measure of variable is the topic of a different article linked below. This property describes how far away the data point tend to fall from the center. So we will talk about this in a different article more. So the graph below shows the distribution with the same central. Now, the graph below shows how distribution with the same central of tendency, that is the mean is what? 100, can actually be what? Quite different. The panel on the left displayed a distribution that is tightly clustered around the mean, while the distribution on the right is more spread out. It is crucial to understand that the central tendency summarizes only one aspect of distribution, and that is provides an incomplete picture by itself. Now look at the graph we're talking about. Look, this is your left hand side and your right hand side. Let's go back again and say the graph below shows how distribution with the same central tendency. The same central tendency is what? 100. The mean is equals to what? 100. Can actually be what? Quite different. Yes, the mean is 100, but the graph is different. The panel on the left displays a distribution that is slightly clustered around the mean, while the distribution on the right is more spread out. It is crucial to understand that the central tendency summarizes only one aspect of the distribution, that is what provides an incomplete picture of it. Now look at the left. It clustered, and then the one at the right hand is what? Is spread. Normal distribution, which was with the same mean but different variability. Are we together? It's the same mean but different what? Variability. The normal mean here is what? 100. However, the different variability we see here, the one by the left hand side is somehow cluster, and one that by the left hand side is what? Is spread out. Let's go ahead. Now We take this measure of central tendency one after the other. Remember, we're talking about mean, median, and mode. Now, the mean. The mean is arithmetic average, and it is probably the measure of central tendency that you are most familiar. Most of us are familiar with mean. Another name for mean is just an average. Just taking an average. And how do we do that? We are quite familiar with this central tendency, isn't it? Calculating the mean is very simple. You just add up all of the value and divide by the number of observations in your data set. Now I've given you the formula to calculate the mean for group data. I've given you the formula to calculate the mean for what on group data in the previous video. In case if you have missed that, please go back and then you will see those previous videos I have posted, and you will learn more about the formula. However, in summary, we have the formula here. All you need to do to find a mean is to what? Add up the numbers together and then divide it by the numbers. Add up the value together and then you divide it by the number. For instance, we have x1 plus x2 plus till the end of the x, that is xn, then you divide it by n. That is the total number. Assuming you have 6 figures, you add up the figures together and you divide it by 6. If you have 5, you add up the figures together and divide it by 5, and so on. Now, the calculation of the mean incorporates all values in the data. If you change your value, the mean changes. However, the mean doesn't always locate the center of data accurately. If you want to locate the center of the data, most of the time the mean may not get. When we say on average, this thing on average is this. Yes, we are trying to locate what are we trying to do? We're trying to find the center of tendency. But what we're saying is that in most cases it may not represent the center. Like you're looking for a center of a tendency and then you apply the mean method. Okay, let's find the average, and you say on average this is this. Most of the time it is not that way. Now, however, the mean doesn't always locate the center of data accurately. Observe the histogram below where I display the mean in the distribution. Now look at this histogram. Look at this histogram. It's a systematic or continuous data. In a systematic distribution, the mean locates the center accurately. In this case now, yes, in some cases, as I said, the mean may not be the best option to locate the central tendency. But here, the center is being located by mean accurately. If you look at the data, the histogram from the left and the right, the middle one is the mean, and it is at the center. Kudos. But let's look at this. In this case, in this arrangement, which is a squeeze continuum, the mean is not the center. The mean does not locate the center. So the difference between this arrangement, yes, in this arrangement you are able to find the mean which locate the central tendency. At this point you are not, you may not get. So what we are saying is the mean in some cases may not locate the central tendency. Now, however, in a squeeze distribution, the mean can miss the mark. In the histogram above, it is starting to fall outside the central area. The problem occurs because outliers have a substantial impact on the mean. Extreme value in an extended term pull the mean away from the center. As the distribution becomes more squeezed, the mean is drawn farther away from the center. Consequently, it's best to use the mean as a measure of central tendency when you have a symmetric distribution. So the mean can be used when you have what? Symmetric distribution. Now let's look at the median. Can we use median to find the central tendency? Is it the best option? Let's look at it. The median is the middle value. The median means what? Middle value. The median means what? Middle value. It is the value that split the what? The data set. Split the data set into half. To find the median, order your data from smallest to greatest, and then find the data points that has an equal amount of value above it and below it. The method for locating the median varies slightly depending on whether your data set has an even or odd number of value. I will show you how to find the median for both cases. In the examples below, I use whole number for simplicity, but you can have decimal places. Now let's look at this. Now in this case, now we're looking for a central point using the method median. Now in a data set with an odd number of observations, notice how the number 12 has 6 value above it and 6 value below it. Therefore 12 is the what? The middle or the middle of this data set. Now this is an odd number. The odd number, of course, we know that there are numbers that can be divisible by 2. We have the odd number. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The odd number, there's 13 here, isn't it? Good. Now, if you arrange this from smallest to the greatest, or vice versa, it can be from greatest to small, whichever way, ascending or descending. You must to find a median, you must rearrange your data sets. Now when you count them, you go up, you have 6 up, 6 below, then 12 become your middle points. Alright. When there is an even number of value, you count it to the 2 innermost value and then take the average. The average of 27 and 29 is 28. Consequently, 28 is the median of this data set. Now look at it. This is an even number. And the first one was an odd number. This is an even number. An even number. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's not like the previous ones. The previous one that you have 13, which you have 6 up and 6 down. This one you have 14. What will you do now? You take the middle. And in this case, the middle here is what? 27 and 29. When you add 27 and 29 together and you divide it by 2, you have 28. Pick up your calculator and do that, or take up your pen and then you write that. Just pause for a while and do that. Okay. Did you get 28? Okay, if you get 28, kudos to you. Clap for yourself. Roll it up for yourself. Let's go ahead. Good. Now, the outer and squeeze delta have a smaller effect on median. To understand why, imagine we have a median data set below and find that the median is 46. However, we discover that entry error and need to change the value, which are shared in the median fixed data set. We will make them all significantly higher so that we now have a increased distribution and large outliers. Now look at this. This is a normal median, then this is a fixed median. Now this is the previous ones that we have, and then look at this one now. Now in this case, we have both 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Both of them are 13 perfectly. But in the left hand side, where you have after 46, you have 46, 46, 47, 45, 44, 54, 56, 69. Now the one in red, the one shaded in red, you see there are altered, we have altered it. Number have increased. Instead of 52 is 82, 89, 93, and 112. What happened when these numbers change? But still, the median is 46. Do you see that? The number have increased, but if you rearrange them, remember we are looking at the middle point. Alright, let's go. As you can see, the median doesn't change at all. It is still 46, unlike the mean. The median value doesn't depend on all the value in the data set. Consequently, when some of the values are more extreme, the effect on the media is smaller. Of course, with other type of changes, the media can change when you have a squeezed distribution. Comparing mean and media. Let's compare. Let's see. Now let's test the media on a symmetric and squeezed distribution to see how it performs, and we will conclude. Now look at this histogram. The histogram of symmetric continuum. Now the mean here is what? 1000, that's 100.67, and the media is 111.06. In a symmetric distribution, the mean and media both find a center accurately. In a symmetric distribution, both mean and media can find the center what? Accurately. They are approximately equal. Approximation of this mean and media in symmetric distribution, they are equal. Now let us look at what? The histogram of a squeezed continuum. In the histogram of a squeezed continuum, look at the mean up and look at the media up with red and then the mean down in green. Now, in the squeezed distribution, the outlier is the tail pull the mean away. The outlier in the tail pull the mean away from the center towards the longer tail. For this example, the mean and media differ by over 9,000, and the media better represents the central tendency of distribution. In essence, in a squeezed distribution, the media can be best used. You can't use mean to determine the center of the tendency in the squeezed distribution. That is what we are saying. When you have a symmetric distribution, good and fine, you can use the mean. But when you have a squeezed distribution, mean cannot be used, just as you can see. So that is what we are saying. Now, these data are based on US household income for 2006 income. 2006 income is what a classic example of when to use the media, because it tends to be what squeezed. Our income is a perfect example because the income tends to what the squeeze. It doesn't flow normally. No. The income tend to skip. The median indicate that half of all incomes fell below what? 27581 and half above it. For this data, the mean overestimates where most household income fell. When the mean overestimate, most of the household income will fall. Now look at this question. When to use median? When to use median? Squeeze distribution, continue data, ordinary number. That is when you can use media. If you want to use media to find the central tendency, you use them in what? Squeezed distribution, in continuous data, or in what? Ordinary data. That is when you can use media. Now, the mode. Remember, we have been talking about mean, media, now we're talking about mode. The mode is the value that occurs the most frequently in your data set. I take that again. The mode is the value that occurs the most frequently in your data set. On a bar chart, the mode is the highest bar. If the data have multiple values that are tied for occurrence, the most frequently you have a multiple model distribution. If not, value repeats. If no value repeats, the data do not have a mode. Well, in the data set below, the value 5 occur most frequent, which make it the mode. This data might represent a 5-point like scale. Now let's look at this. How do we get the mode? As we said earlier, the mode is the value that occurs the most frequently in the data set. Now look at this. Look at this now. Here we have 1, 2, 2, 3, 4, 4, 5, 5, 5. Now let's take this as in a class of 1, 2, 3, 4, 5, 6, 7, 8, 9 people, 9 students. In the class of 9 students, and a test is given, mathematics test is given over 5. Now 3 students score 5 over 5. 2 students score 4 over 5. And then 1 person scored 3. And 2 people score 2, 2. And 1 score 1. In this case, when you are representing this data, the mode are the highest number and you put them together, you see that those, you call them, come outside. The 9 of you come outside. How many of you scored 5 over 5? The 5 over 5, there are 3. How many of you score 4 over 5? 4 over 5, 2. How many of you score 3? 3. You have 1. And then how many of you score 2? 2. Then, in this case, those that score 5 have the highest because they are 3. And they are the mode in this, what we are talking about, in this data set. I hope that explanation makes sense. Are you clear? If you're not clear, read it again, and then go back to the video again, you understand. Now, typically, you use the mode with categorical, ordinal, and district data. In fact, the mode is the only measure of central tendency that you can use with categorical data, such as the most preferred flavor of ice cream. However, the categorical data There isn't a central value because you can't alter the group. You can't alter the group. The ordinary and district data, the mode can be a value that is not in the center. Again, the mode represents the most common value. So in essence, what we are saying here, typically you use the mode with categorical, ordinary, and district data. In fact, the mode is the only measure of central tendency that you can use with categorical data. Such as the most preferred flavor of ice cream. Remember, go back to your categorical data. You see where we make illustration on what the categorical data of the preferred flavor of ice cream. Now, let's go ahead. This is it. This is what we refer as what? Categorical data. With categorical. It has category. This is the category of the data. And then satisfied is the mode of this distribution because it is the most common value in the data. Let's look at it. Look at it. This is satisfied here. This is very satisfied. We have very dissatisfied, and we have dissatisfied, and then we have normal, and then we have satisfied, and we have very satisfied. Now 1, 2, 3, 4, 5, and then we say satisfied is the mode of this distribution because it's the most very satisfied is the mode because it's the most common value in the data. Notice how it is the extreme end of the distribution. I am sure the service provider are pleased with this result. So in essence, what we are saying is what this very satisfied is the what is the mode. Now find the mode of continuous data. In the continuous data below, no value repeats, which means there is no mode. With continuous data, it is likely that 2 or more value will be what? Exactly equal, because there are an infinite number of value between any 2 value. Look at this. This is the data, the mode. There is it. You go through it. We have from down, we have 5.762, 89.483, 92.619, 94.724, 96.221, 98.228, and 102.691, and then we have 103.079, we have 109.085, 122.275. Good. Now, when you are working with a raw continuous data, don't be surprised if there is no mode. However, you can find the mode for what continuous data by what locating the maximum value of the probability distribution plot. If you can identify a probability distribution that fits your data, find the peak value and use it as a mode. In essence, what we're saying here is that sometimes you may not have mode. For instance, in the illustration we gave before, the 9 students, and whereby maybe all of them scored different figure. No mode. Mode will not be found, or all of them score equal. What will you do in that case? So in some cases, when you are working with a raw continuous data, don't be surprised if there is no mode. However, you can find mode for continuous data by locating the maximum value of the probability distribution plots. The probability distribution plot displayed a log normal distribution that has a mode of 16,700. This distribution corresponds to the US household income, example in the media section. Now look at this. This is a squeezed continuum probability distribution plot. This is a log normal data set. All right. In summary, let us answer the following question. We use this question to summarize our teaching for today. We use it as brain test, we use it as classwork, and we use the question as summary. Question number 1. When to use mode. Remember, we said when to use mode. You can use mode in what? Categorical data, ordinary data, count data, probability distribution. That is where you can use mode. The answer: when you have ordinary data, the median or mode is usually the best choice. For categorical data, you have to use what? Mode. That is the answer. The question is when to use mode. Is it categorical data, ordinary data, count data, probability distributions? And the answer is when you have ordinary data. The median or mode is usually the best choice. For continuous data, you have to use what? Mode. Now let's go to the next question. Which is the best? The mean, the median, or the mode? Which one is the best? Measure of central tendency. Someone will ask, sir, which one is the best? The mean, the median, or the mode? Now, I put that to you. Which one do you think is the best? Oh yeah. Think before I'll give you my answer. Okay, your guess is as good as mine. Let's go. Answer: when you have a symmetric distribution for your continuous data, the mean, median, and mode are equal. In this case, analysts tend to use the mean because it includes all of the data in the calculation. However, if you have a squeezed distribution, the median is often the best measure of central tendency. Assignment number 1. Which of these statistical number is the middle number of the data set? Very simple, right? Mean, median, mode, range. Which one is the middle? Simple. Okay. Question number 2. Mr. Choren took a sample of 50 pieces of data. He added up all the pieces of data and then divided by 50. What measure of center is he working on? Is it a mean? Is he working on a mean? Is he working on a median? And is he working on mode, or is he working on range? Okay. Right. Question number 3. A set of data is given 3, 7, 11, 11, 16. Mr. Choren calculated a measure of central and then got 9.6. Which measure of center did he just calculate? Is it mean, medium, mode, or range? Question number 3. Hope you're writing it down. 10, 20, question number 4 rather. 10, 20, 30, 30, 35, 44, 50. Take that again. 10, 20, 30, 30 again, 35, 44, and 50. For the last time, 10, 20, 30, 30 again, 35, 44, If I add 10 to each piece of data to make a new data set, so if I add 10 to each of them, I will have 20, 30, 40, 40 again, 45, 45 again, and then 60. Which data sets calculation will not change? Which data set calculation will not change? This should be data sets calculation will not change. Mean, median, mode, or range. Calculate the median of this set of data. We have 22, as you can see. You are seeing it on the screen. You have 22, you have 32, you have 44, you have 11, you have 5, you have 28, you have 19, and you have 30. Calculate the median for this data set. And what is your answer? Write it down. Then question number 6. Calculate the median of these data sets. You have 100, you have 55, you have 95, you have 140, you have 101, you have 98, you have 53, you have 57, you have 70. Calculate the median. Is the answer A? Is it B? Is it C? Or is it D? Give me the answer. Question number 7. Which set of data has the highest mean? Bill. You have 1.3, 3.1, 4.1, 2.5, 2.2, and then 2.8. Then you have Megan. Have 5.5, 1.1, 1.2, 2.4, 3.8, 2.0, 1.8. You have option A, B, and C. Now, thank you very much for staying tuned to the end of this. If you have a question, this is my contact. You can reach me through either you email me or you send me a WhatsApp message or you call. I will answer your question. However, apart from this video, I'm going to upload the format of PDF, the PDF format of this lecture or class or lesson, so that you can also follow. You read it on your own and you listen to the live video, and then you answer all the questions in your assignment. At the same time, you have any comments, and we like to know. Thank you very much once again. Thanks for your audience. I'll see you again in the next class. Remain blessed. I still remain Mr. Choron. My name has not changed. Thank you.